it's in quite a controlled stream and the flow's not very high.
Right.
So it's a bit like, I don't know, if you put your hand over a kettle, sort of here, if the kettle's here. So you wouldn't, unless you really held it
there and let it collect,
it's slightly safe, but it is. There's kind of, there's no other way to do it.
Yeah.
There's other things that people do sometimes, like you can heat the coils themselves, but this is the most straightforward way. But it does seem a bit like it is very janky, and it's just kind of no other way to do it. Okie dokie. So now we can actually do an experiment. I would skip this bit.
Yeah.
Right. So you can skip from where it says hardware boot and then tuning the magnet. This magnet basically never becomes untuned for the sort of samples that we're measuring, so everything's similar enough that everything's basically in tune. If you do that, then it changes some parameters in the configuration. You need to know where those parameters are, and if you forget, then your signal will be crap. So it's best just not to do that. I can show you what that looks like. Fun. It's fun. There we go, it's in tune.
Right.
It always looks like that.
Yeah.
And the annoying thing is that when you do that, it changes this value here from 20 microseconds to 3.34 microseconds.
Right.
And what that does, it puts a really, there's a delay at the beginning of the acquisition, because there is, when you tell the machine to go, there's a delay between it going and you acquiring data. So if you don't put an acquisition delay in, what happens is you see an increase of intensity at the beginning while it's acquiring to start with, while it's kind of switching on, and you don't want that because it will ruin your fit. So basically what we do is we say, okay, it takes the machine about 10 microseconds to switch on, so we'll give it a 20 microsecond delay so that we know when we're acquiring actual data and not just a turn on.
Okay.
But the problem is when you tune, it sets like 3.34. If you forget, then all the data will look shit. So this is what you do. Alright. So the next thing we do is go. Sorry, I like that. So we're going from here. So experiment, there's drop down, and then we want NP to start with.
Yep.
And this is the simplest sort of experiment that this machine can do. So basically what happens is there'll be a single 180 pulse. That pulse will be spin in the higher energy state, and then they'll decay, and then we record the intensity. And so we do this so that we can tune the observe offset, this number here, which is basically the frequency of the receiver, as opposed to the frequency of the thing that's causing the signal. So there'll be some delay between those, and we want to account for that so we get the maximum amount of signal. There's a load of stuff you can read about this on Wikipedia, but it's very dry and boring, and I don't think Mike will care. But that's what I'm doing. Some people are really fascinated and need to know why they're doing these things, and it is. Okay, so we've done that, and then we're going to do this relaxation field of 7 megahertz. So to change any of these values, you just click where the values are, and then change the number. So we're going to change relaxation field to 7. That's that bit there. And then file, you can save the file name. So if you go to where it says file, click on the empty space, and then make a data folder for yourself. Okay. And then what I suggest you do is call it something that allows you to recognise what the data is, obviously. So let's go PEO 300 at 30C. Makes sense.
Why is the PEO 300?
It's 300 grams per mole.
Okay.
And then so there's 300, 400, 600 and 1500. So now what it says is you should set, oh yeah, so the acquisition delay is 20 microseconds, we've done that. And then it says set recycle delay to 5T1. So what that means is that what you want is the delay between experiments to be longer than your T1. If it's not longer than T1, then, so you got all your spins pointing up here, you send in a pulse, they all go down here, then you wait for some time. If you don't wait enough time for them to go back to their ground state and start another experiment, then the next experiment will be wrong by some factor. And then that will keep going perpetually, so the more experiments you do, the more wrong you are, and then your intensity will be wrong. So the way that we solve for that is by leaving enough time between experiments such that all of the spins go back to their ground state. So the spins, we excite them, leave enough time, they go back there. And they're jumping all the time.
I mean, if it was on fire, we wouldn't have to do the experiment.
Yeah, we would. Yeah, exactly. The swings are roundabouts. So we don't. So the problem with this setting 5T1 is that we have no idea what T1 is. I mean, I know what it is.
So we're just guessing at the moment.
So we're guessing at the moment. Yeah. So the best thing to do to start with is guess that the T1 is about 0.2 of a second, i.e., set recycle delay to a second. If it's wrong, which it is, a second is far too long. But I'm going to set it to a second so that...
But why would it be... What's the problem? If it is too long, would that still work then?
So... Yeah. So if it's too long, it doesn't matter at all.
Yeah.
But it makes the experiment take longer.
Yeah.
So if you're doing
Not
16 points per frequency and you set a recycle delay of 5 seconds, that means each point is 5 seconds. That's 16 times 5 per frequency point. And then your profile, you get 20 points. So it's 20 points times that. So it'll take about 45 minutes. If you set it up properly and just enough time, then each one of these experiments takes about 10 minutes, 5 minutes.
Yeah.
So it's not a... Yeah, from an experimental point of view, it doesn't really matter. From a madness point of view, it's better for you guys if you can get your experiments done in a week, you know. Don't have to stay here overnight. But I'll show you what it looks like when it's, when it's too long or too short.
Okay.
So it's the reason why you can see it's wrong is not because the recycle delay is too long, but because of the way it sets up points. I'll show you.
Okay.
There are a lot of things with this, but basically at the moment, I'm only using it so I can show people what to do. And so there are a lot of things where I have to remember, like, why do we do that again?
Yeah, I can imagine.
So you set both of these to the same thing.
Okay.
So at the moment, I'm assuming that T1 is 0.2 seconds. And then gun. So you click the gun to go. I don't know why it's a gun, but it is. And then that'll go, take a second, and then that's the signal. That's what it looks like when it looks like nice.
Okay.
When it's finished, you click save. That sends the data.
Is that finished?
Yep.
That was fast.
That was, that's just one pulse.
Oh, right.
So this is just the preliminary setup, but this looks pretty good. If you get something that looks like that, you've got something in there that is giving you signal. If it looks like a load of wiggly lines in the middle,
A lot of noise.
That means most likely that either TX isn't on, or that your sample isn't in there properly.
Okay.
Like 99.99% of the time, it's just, or it's not high enough. Yeah. So that's done. So the next thing we're going to do is set up the length of the pulse that we send in. Again, this is something that it says in the manual that you should do every single time for every single temperature, every single sample. What I would do is do it once per sample. It really doesn't change that much, and it's annoying. So I think do it once, and then you can skip to the actual bit. So set here, and then we need to do the same thing. So we set recycle delay to 5 times T1, which is 1. We'll set the relaxation, the polarization time to 1 as well. It says that in here. So yep, set relaxation delay and polarization time t-pole to 5t1 to a rough estimation. That's what we've done.
Yep.
And then it says there, go to acquisition parameters, go to endim, and then change this 15.5 to 16. It doesn't matter because it rounds it up anyway. But we'll do it.
Okay.
And then whoop, then keep going.
So, what are we doing now then to it? What
What we're doing now is we're doing exactly the same experiment again. So all of these are that single line that we saw for the non-polarized pulse. Except what's happening now is that the length of the radio frequency pulse that you send into the sample is changing. So what we're trying to do is adjust that length for future experiments such that we get the maximum amount of signal.
Okay.
So you see that this is a sine wave.
Yeah.
So basically we want the top of the sine wave, and it will keep going forever. So if you have a pulse length where the maximum's at 5 microseconds, there'll also be another maximum at 10, really slightly lower, so you can set it to all these maximums. So as long as you set it somewhere there, it means you'll get decent signal.
Yeah.
For these samples, it doesn't really matter so much, but for other stuff, it can make a hell of a difference. Okay. So then, click save. And then click the evaluation dialog button, which is this 1-2 button here. Somebody's drawn a picture. And then to analyze this, you use WAM, which is taking the data in the window and getting the absolute magnitude. And then that'll give you this. You click on the peak, you'll see that X says 5. It says 5 seconds. The software is wrong. It's 5 microseconds.
Right.
And then what you do...
So we're just estimating the peak then, or we're not finding it out?
No, as long as you're about there, it's fine.
Okay.
Even if you set it here, you still work. If you set it down here, it would look like crap.
Yeah.
So then what you do... So what it says is that you should change this. So you should go into acquisition parameters, then configuration, and you should change this number to the maximum here. You'll see this grayed out at the moment, and it's always grayed out after an experiment finishes, and so you can only edit this value when you set up a new experiment.
Right.
So you set up a new experiment first. So the new experiment is called NPS, so this is like MP, except that we do it over a number of different waiting times, basically, to find out what the signal is. I'm going to turn this down. It's really hot. Okay. So at the moment, we're assuming that our maximum T1 is 0.2.
Yep.
So it's at 0.2 there. We're going to do this at 7 megahertz. And we're going to go to go to conf, acquisition parameters conf, and then change this guy to the maximum here, so which was about 5. If it's between 4.5 and 5, that's okay. If it's anything different than that, something is definitely wrong.
That's what